All right, this week we are going to start equations of proportional relationships. Last week we looked at what proportional relationships are and how we graph them. So now we're going to look at equations. Go ahead and take 5 minutes to answer these questions. When you're done, come back. All right, so number 1, 2 times x minus the quantity 7 times y equals 20. So if we have 2 times x. All right, that looks really confusing. When I'm writing variables in my equations, I can just put it right next to my number. So we have 2 times x minus the quantity 7 times y. So minus 7y equals 20. That's number 1. So when it says the quantity of, sometimes I need parentheses, but when I'm doing multiplication next to division, I don't need it. Number 2, the quantity 10 plus x divided by the quantity 3 times y equals 44. So if we have the quantity 10x divided by the quantity 3 times y, equals 44. Oops, I'm writing weird. 44. So that's super sloppy. That's how you would write that equation. I think I got all the facts in there. So number 3, x equals 11 plus y. So 3, we have x equals 11 plus y. That one was pretty straightforward and easy to write. Number 4, y divided by 9 equals 3 times x minus 5. So y divided by 9 equals 3 times x minus 5. The last one, Joe mows lawns. He charges $15 plus $4 times the number of hours, age it takes. What is the equation for the cost, C, to mow a lawn? All right, so we know we're looking for C, the cost. We need to know how many hours he mowed at $4 an hour plus his flat rate of 15. All right, let's look at how they wrote their answers. So you can see 2x minus 7y equals 20. 10 plus x, I think I wrote this one wrong, over 3y equals 44. X equals 11 plus y. Y divided by 9 equals 3x minus 5. And C equals 15 plus 4h. Remember, in math, we can do things in like whatever order we want as long as it's addition because of different properties. Not any order, but all right. What are we doing today? We are still working on recognizing and representing proportional relationships between quantities. We are going to identify the constant of proportionality or unit rate. Remember, those words mean value, or they're the same for their value in tables, graphs, equations, diagrams, and verbal descriptions of proportional relationships. We are looking at equations today. Represent proportional relationships by equations. So, how can you meet this? I can write equations to represent proportional relationships and identify the constant of proportionality in the equation representing a proportional relationship. Some more practical use of this. You can make connections between the unit rate and the constant of proportionality and how it is represented in an equation. You can model a real-world proportional relationship with an equation, so that's like our mowing the lawn. I can accurately write and solve equations using variables with proportional relationships. You use these things when you know that you have to buy 15 of something and you know the cost. That is a proportional relationship. Vocab today, our vocabulary, we have proportional relationship, which is 2 quantities. The ratio between is the same or equivalent. A proportion is the equation that shows that. So let's look at the launch. At top speed, one of the fastest elevators in the world travels 45 miles per hour. The equation y equals 45x can be used to find the miles y traveled in hours. Okay, so I want to go in that elevator. That sounds awesome. Suppose you could ride this elevator up for 1 minute, as far as it travels, 45 miles per hour. How could you use the equation y equals 45x to find the distance you will travel? All right, so we're going to add some space here. So we know y equals 45x in our equation, where y is the distance and x is the time. That is not a good arrow. All right, so I'm traveling for 1 minute. However, I know this is 45 miles per hour. So that's 45 miles to 1 hour. How am I going to write to 1 minute? So, well, I could write it as 45 to 60 minutes, but I want to know 1 minute. So 1 minute is 1/60th of an hour. So now I can solve this equation. Y equals 45 times 1/60th. So if I put parentheses around numbers, that means times as well. All right, I really don't want to, so now I have two fractions. So let's do y equals 45 over 1 times 1/60, right? I don't want to multiply big numbers. So I know, 45 and 60. 45 ends in a 5, so I can divide that by 5 because 60 ends in a 0, which is also divisible by 5. So 45 becomes 9, 60 becomes 12. Ooh, those are better numbers. Ooh, but I know that 9 and 12 share a factor of 3. So 3 and 12 becomes 4 when I divide by 3. So now I have some simplified numbers I can use. So now I have y equals 3 over 1 times 1/4. I'm going to multiply across and be y equals 3 over 4. So in 1 minute, I can go 3/4 of a mile. That's pretty far in an elevator. I don't know that I would want to be stuck in that elevator that long. So let's go on into, I hit the wrong button, our next resource, exploring equations. If it'll load. All right, so now we're going to look at proportional relations and equation, and we're going to use the web sketchpad for this. So let's go. So the sketch graphs show the relations between the time and distance of a balloon that has been launched. Press the launch button. So let's see if this appears to be proportional or non-proportional. Let's reset this. So launch. So we're going up. Remember, 2 facts about proportional relationships. They have to be in a straight line, and they have to go through the origin, which is 0, 0. Remember, the origin is where our x and y axis cross. So look, this one has a point at 0, 0, and it appears to be in a straight line. The equation is y equals 0.345x. I could plug these in and figure out what each one is. And it would be the same. This appears to be proportional. It goes through the origin. It's a straight line. X has a coefficient of 0.345, which that coefficient is the number I multiply my x by. So my x is going to be my time. So I could tell you that balloon was flying for any amount of time, and I could tell you what height it would get to. So let's look at the next one. All right. So this one here's the second balloon. So let's see what happens. Again, remember, a proportional relationship has to go through the origin and be straight. So when this is done, this appears to be a pretty straight line. But when I get down here to the bottom, that's not going through the origin. So this is going to be a non-proportional line because I don't go through the origin. So if I show that equation, I have y equals 0.58x plus 10. Well, I have a coefficient, so that's telling me one thing, but that plus 10 tells me I've moved everything up, so it is no longer going through the origin. If I put 0 in for x, I'm not going to get 0 in for y, or 0 in for y. I'm not going to get 0 for x, and vice versa. 0 in for x, I'm not going to get 0 for y. In order to have proportional, it has to be 0, 0 as part of your graph. And our last one, let's look at another example. All right. So again, look, we have a straight line, or what appears to be a straight line. I don't have the line graph, but that looks to be pretty straight. And it goes through 0, 0. This is going to be proportional. If we look at the equation, we don't add anything else. Our coefficient is 0.46. That's what we're multiplying our time by to get our height. So this is a proportional relationship. So now let's look at these. The equations represent the relationships between the heights of the balloons and times for each balloon launch. Drag the equation to each bin that describes the relationship as proportional or non-proportional. Well, we said the one that we add things was non-proportional because it doesn't go through the origin. But the other two, when we graphed them, went through the origin. So the proportional ones are called a one-step equation, whereas the non-proportional is a two-step equation. So this is something that's important that we'll learn and you'll use as you go through math more and more. Right now, notice the proportional doesn't add anything else. The non-proportional looked like it was proportional, but it didn't go through the origin. The origin is a critical piece of whether a relationship is proportional or non-proportional.